Okay, so we're going to go and start creating our first program ever together. And so you should already have BlueJ installed on your computer. And anything we do together in class, I'm also going to upload to this shared folder and put it in the Unit 1 folder. You don't really need to look at these yet, but there'll be other little folders in here for each program. So on your computer somewhere, you're going to need to find a place where you're going to keep all of your programs in a very organized way. I'm going to ask you to specifically name them a certain way and organize them a certain way, so it's very easy for you to find them and for me to, when I come to look at your program, you can easily find it, and we don't have to sit around, fool around trying to find stuff. So we can actually create that as we create our first program. So if you go to BlueJ, the little BlueJ symbol, and open it up, create a shortcut on your desktop would probably be good. It opens this window up. And so this is just a blank window. Now, if you've done any projects before, it might open up the last project that you were working on. So you would go to project and then close it. Now we're going to create a new project. So this will be the first step. New project. And what I would recommend right now is that you have this on your screen and that you have this side by side with you doing the same thing, so that you can kind of when we do these kind of lessons together, you're really just going to be kind of following along and doing what I do. But these lessons will be very infrequent, and most of the time you guys are going to be working on assignments yourself. But at the beginning of every unit, we're going to start. Now, it might bring you to some folder. I'm going to create a folder. Oops, I went a little too far. I have a computer science folder on my computer. So I don't know if you want to create a computer science folder, but I'm going to create a folder. So you can go up here and create a new folder, the one with a little star. And I'm going to call mine APCS, AP Computer Science A 2020, because that's what year it is right now that I'm making this video. So that's what I'm going to do. So you can create it, and then you can double click on it. Now, in this folder, I want to create another folder for Unit 1. So I want all my Unit 1 stuff in a particular folder. So you need to create a Unit 1 folder within your, whatever you're creating. Now, whatever folder you're creating, where you create it, you need to be able to access it. And so I'm creating a Unit 1 folder. So I want everyone to have a Unit 1 folder and just call it Unit 1. And then I'm going to double click on that. And in here, this is where I'm going to create my first project. Now, I don't actually have to create the folder for it. It will create its own folder. So the way I want you to name these, and I want everyone to name these the same, I'm going to call this one, let's see. So, 1 second, let's see. Okay, so I want each one to have this naming convention. P for project, P1, and this is Unit 1. So all the Unit 1 projects will be P1. Now, usually you would put a letter next. I'm just going to call it Z, but you'll call yours A, B, C, D. Or I don't know, I'll call mine, we're going to do a few of these, W, X, Y, Z. I'm going to call it V. So you call yours V right now too. P1VProject. Then we know this folder is specifically project. Now I'm going to hit create, and it's going to create the folder for it. I finally found the spot where this is the actual project folder. And what it does is it creates a folder to hold all the files for this project that will allow it to work. Okay. If we go to that folder now, let's see, it's not going to have all let's open up that folder and we'll be able to look at what's happening to it. So find wherever you put that folder. I created a Unit 1 folder, and now there's a P1V project. Now, if you go in there, there's a couple things already. There's a package, and a README file. Okay. So the package is what runs the program, but there's going to be some other files that get created here. So we can minimize this for now. Now, I guess maybe I'll maximize this screen just to make it bigger on yours. And I'll try and make the font bigger when I'm creating this, just so it's easier for you to see. Like I said, have this taking up like half your screen or whatever. And then be doing the same thing side next to it. Now we've created the project. So the next thing we're going to do is we're going to create a class. So every program we do is going to start with at least a class. And most of ours will just have a single class. So you hit new class, and it says create new class, and it's all these different types. Right now, by default, it selects the first one. This other stuff here doesn't make any sense for what we're doing right now, so you don't need to worry about that. So the class name, this is where you're going to name it. And I want you guys to, this is where you can have a little leeway in what you name it. You can name it something that kind of seems relevant to the actual, the thing we're going to do. So I'm going to call it My First App. And this is, when we name these, I want you to lead with capital letter every single time. And I don't want any spaces or dashes or anything like that. And any other words, what we do is we just capitalize the first letter of the next word so that you can actually kind of read it, even though they're all crammed together. And that's called Camel notation. So we'll put some, when we write our code right now, we're going to add some notes along the way in the middle of it, just as a reference for you. So then we press OK, and it creates this little box right here. Now this box has these lines in it because it isn't compiled. You can't run it yet. So what we're going to do is you could either double click on it, or you could right click on it and say open editor. So I could do that, and it opens this up. Or I feel like I usually just double click it, and it opens up this other window. Now this is the editor. This is where we can actually type the code. Now this IDE, Integrated Development Environment, BlueJ, puts a bunch of stuff automatically in here. And I don't want us to use any of that, because I want us to really get the hang of typing all on ourselves. So the very first thing we do after we create a new class is just delete everything. Okay. And, one of the ways you're going to get better at remembering what to do is just by doing it every time. And when you guys take tests, you're going to have to be able to remember just the basics. And on that very first test we take, some of you guys are going to get stuck on just some of the basics. So now this is what we always need, right? Public class, and then it should and this is where you should put the name of the class, which is up at the top. Now if you change it and then you save it, I think it'll automatically change the outer one too. Now I should make this font bigger so you guys can see it bigger. So I can do this, and these are some different things you can play with too. You can go up to options and preferences, and I'm going to make my font size bigger. I don't know if 24 is going to be too big. I don't know. So I think I'll go with that, and then I'm going to actually make this bigger to take up my whole screen. So I think hopefully you guys can read that. So public class, my first app. So this is going to be at the top of every one of our programs for a while. Now in this class, there's going to be a lot of things you don't understand why we're doing them, because you would have to understand everything to understand it. But I don't want us to have to understand everything before we write our first program, because we probably won't be able to understand it very well. Writing programs is going to help you understand these ideas as I teach them to you. But there will be stuff in these programs that you just have to accept for right now that I can't explain to you yet. Now, as the class goes on, you'll be like, oh, that's why we do that. Okay. Now we're going to put some comments here. The way you write comments, one of the ways you write comments, and comments are just like little things in the middle of your code that aren't actually code. And so you want the compiler not to read them as code, because otherwise it'll probably give you errors. And so we do a double forward slash is one way you can insert comments in the middle of your code, which is good to help yourself, understand what the purpose of that line of code is for, or someone else. Because often in computer, in software, You're not the only person working on software. You're in a team. Other people in the future are going to work on your software after you're totally not even involved in it anymore. And comments can be very helpful in them understanding what your code is. So I like to do double slash, put a space so it's a little easier. So I'm putting some of these some of the things I'm saying I'm going to put in here, and I want you to put them in here too. So use Camel Note. This is called Camel Note notation. When you start with a capital letter, and then you go lowercase for the rest of the word, and then you start with a capital letter for the next word. And we often use multiple words to name things because we want meaningful names. Okay, we don't want to just say, I'm going to call my first program or pro, or let's use something more descriptive. Um, Another comment to put up here is that the way we name classes, which is what we're working on right now, is that you're starting with a capital letter. You always should start with a capital letter. Now, if you don't, it'll work. But this is common. This is just kind of expected. Okay, we're going to name things in different ways, and that will give a clue right away as to what that thing is. And so the name of class should always start with a capital letter. Then we're going to do curly brace. So everything in this class is going to be in between a set of curly braces. Okay, so you could, if you want, open and close them right away, which might be a good idea because sometimes you're going to get errors, compile time errors, because it won't compile because you're missing a curly brace somewhere in the middle of all your code. There's going to be lots of sets of curly braces. So I'm gonna go ahead and end. I'm gonna close it, and I want you to comment every closing curly brace, because then that will help you know which one it's supposed to match up for. So there's a bunch of things we're going to do to help us kind of keep our code, organized. So we're going to say, let's go ahead and say this is the end of the class, in class MyFirstApp. Okay, and the next, everything inside these curly braces, I want you to tab in. Okay, so I just hit the tab button. Now, some of you guys, it's going to do that automatically for you, which you might find appealing. But I've found in this IDE, it kind of sometimes gets a little hard to deal with. And so I personally would go to, and you're going to want to do this eventually probably, I'm just telling you from my experience. And so you might as well just do it now. Go to preferences, and it's going to have auto indent entered right now. I would uncheck that. Okay, I would uncheck that. And display line numbers just gives a number next to each line of code, which you could display maybe sometimes as a reference, like, hey, line 25 in the code, this is, could you look at that for me? Our programs are not going to be that long right now, so that might not be as useful. So I would undo the auto indent. Okay, you can pick like colors and stuff in here. Anyways, so I would take off the auto indent and just hit tab, which I think is equal to 3 spaces. 1, 2, 3. Okay, but tab is quicker. So I'll just tab, and the next line of code, all the lines of code are going to be tabbed in at least once. We're going to do public static void main parentheses string with a capital S. Capitals make a difference in this. String args, and then brackets, and then close the parentheses. Now, anytime we do parentheses in our programs, I personally want you to put an extra space at the beginning and end so that it's easier to read. Okay, so now, like I said, I'm not going to explain what all these things need, but a main, this is actually a method. We're not really getting into that yet. And a main method is always required for any program to actually just run it. So we're always going to have a main method in all our programs for the rest of the year. I want another curly brace right below it. And then you could tab in. I mean, it's up to you if you want to. And then go down here and hit a closing tab. Close that tab and let's comment it. And we're going to say end method main. Okay. And just as another comment here, we're always comment your closing curly braces. Okay. I'm going to require that to give you credit. Now, once we're inside this set of curly braces, we're going to tab in. Everything in here is going to be tabbed in one more. And that's going to help us. This structure is going to make it easy. These tabs aren't required for the program to run correctly, but they're just to make the program easier to read and help you see things. So what we're going to go ahead and just type some different things in here. System with a capital S. Okay, system.out.println, and I'm going to, and again, these parentheses, I want extra space, put quotations high, ... This is Sam. Close the quotations, extra space before we close the parentheses, and then a semicolon. Every line of code in here is going to have to end with a semicolon. That's what tells Java that this is it. This is the end of the line before you go to the next one. Okay, before you try and run the next one. Now these ones up here don't, but this is like an actual command. So this is one of the ways we can print stuff out to another screen. Okay, and so let's go ahead and just start with that, and let's compile it now. So if we close this, it's going to still show the lines, but compiling it will also save it. So we're going to go to this compile button up here on the left, upper left corner, compile. It says file saved. If there's an issue, you're going to get error codes down here. This says no syntax errors. That means syntax is what you've typed. Everything you've typed is legal, follows the rules of Java, and it at least understands them. Okay, that doesn't mean it's going to run the way you want it to. You can have logic errors that still bypass. So I'm going to close this, and now we see the lines are all across here aren't there anymore. So I would right click on this. So we want to run it, and you're going to go to void main string. So this is telling it, please run this method. And this is the way that all programs, they have to have a main method. Okay. So right click, go there, and left click on it, and then say okay. And it opens up a new window. This is an output window that prints that message. Now, before we run again, I would clear it and close it. Now let's go back here. So what we just did, the system.out.println is a way of printing a message out to an output screen. And that's what we did. We had to put quotations around it for it to know, okay, this is something to print out. Next, let's create some other variables. In general, I want like extra lines, extra blank lines between kind of chunks of code that, kind of are separate. And again, that's just to make it easier to read. Let's create a variable of a type int. And that means it's an integer. There's different types of integers. And I'm going to say that equals 5. Now, what we've just done is we've created the variable. The variable is called x, which is going to be very unlikely that we're going to use that simple of a name for a variable. That's the name of it. This is the type of variable it is. And then this is its value, its initial value. So let's put some comments here about what we're trying to do here. Just so you can remember. So this is, we are declaring a variable of type int. Okay, that's what we're doing right there. Declaring the variable, that's the first part, of type int, and initializing, that's when you give it its first value. It's value to 5. Okay, so that's what we just did there. And just as another comment, name variables with a lowercase letter first. We got to start with a lowercase letter. And then you can put capital letters inside. I'm going to show you guys some examples of that. But like we always start the class names and the class names need to start with the capital. Okay, now let's do another variable of type double. A double is like a decimal. Okay, and I'm going to call this cost, which is probably more likely that we're going to have more meaningful names. And it's double, so I'm going to initialize it to some kind of decimal, 1.99. Okay, that's a different type of number that's stored in Java. And let's put another comment right here. Use meaningful variable names. So in general, I don't want to see X, Y, Z unless that really makes a lot of sense for what it is. Usually we're going to use words, multiple words. Okay. Let's do another one called Boolean. And that's a data type in Java. And these are called primitive data types that stores either true or false. That's it, true or false, which is very helpful in a lot of programming. I'm going to say is charging. And I'm going to set it to true initially. Now we can change these values later on. So I guess I'm not going to put a comment on there. Usually with Boolean, a lot of times it is true or it's not. So is it charging or is it not charging? So like is charging is kind of like a good variable name for the state of it charging or not, and that's true. And if is charging is false, then that means it is not charging. So a lot of times we start the Boolean names with like is something else. Now we're using the camel notation. So we still use the camel notation if you can use multiple words to name anything, which we will want to do that. But the first letter had to be a lowercase because these are variable names. Okay, now let's create another variable of type string, and that's like a word. You want to store letters. I'm going to call it name. And now here's the thing: string. You might notice that the type start with the capital letter because it's actually a class. It's an object. It's different than these primitive variable types. And so it's an object, and usually when we create a new object, we have to say new string and then give it an argument is what it's called. So I'm gonna create a variable called name that holds a string, and I'm gonna put my name in it at first. Okay, so let's add some comments here. Declared a variable called name of type string. And if your comments get too long, what it might be better to just go ahead and start a new comment on the next line so it doesn't like wrap around. So this whole thing with new creates a new string object. And another word that gets used a lot in computer science or in Java for when you create a new object is they call it instantiating. So we instantiate that. It's like when you first create it, a new object. All right. Let's see. Let's print some different things out now. So usually, one of the ways that we print things out is to do system, capital S, dot out, dot println. And what we can do is we can put a message like the value of X is then actually put the value of x after that. So we got to put quotations around the message, but then we can add this value afterwards. And I left it extra space so that it wasn't right next to that colon. And x isn't a letter or a word, it's a number. But if you do it in this way, it will print it out as like a letter. So let's try that out. Let's see what happens. Let's compile it. We got to compile it again. And then we could close this and go up here, and we could right click and then go to void main string and hit OK. And it had the other thing. This is the value is 5. Now, if I don't clear this window, if I just close it and I run it again, it's going to have the previous output on there also. So I like to clear it, or Control K for quick, before I close it, so that I get a fresh, thing. Now, we could, now here's something else. System.out.println, and we can just put the cost in there, and it'll say, okay, cost is like a number, but it'll turn it into a word to be printed on a screen, or into symbols, characters. So compile. Let's run it again. Void main string. Okay. Now I'm going to clear it. Now here's one of the things that we could do. If I take out this ln, which stands for line, or actually it stands for new line, if I take that out of this, what's going to happen is it's going to print. The new line tells it, it's kind of like the inner key. It tells it, okay, go to the next line after you've printed this. If you don't do that, then it's going to print the next thing right next to the last thing. So let's just see how that works. Sometimes you want to do that. So if we go like that, see, like it said the value of x is 5, and then it has the 199 right next to it. So that's what the new line, that's the difference of what the ln does, is it puts it to the next line. So for right now, we're, that's kind of something I think we want. Oops. Now, if you make a typo, like I just did, let's just leave that for a second and see what happens. Ln is charging. So that's not going to print is charging because I didn't put quotations around it. It's going to take the value in that and print it. Now, if I try and compile right now, it's going to say package sys does not exist. So they're saying we don't know what this is. They know what system is, and there's a bunch of other packages that have these little programs that are already built in on how to do different things, and it says we don't know what that is, and it highlights it for you. So that's kind of one of the nice things about IDEs. Now, if I come on now, let's go ahead and we could do system.out println name. Now let's see, if we forget the semicolon, what does it do? It says, hey, look right here, semicolon's expected. So hit compile. And so, I don't know, let's go and run what we have right now. Right click, void main string, okay. There you go. Now, what if we wanted an extra blank line between this and some other stuff? So I'm going to clear that before we go back here. Now, there's some different ways to do it. If you just put an extra line in your extra blank line in your code, that has no impact at all on how the code works or what it prints out. But what we could do is we could say system.out.println and put empty parentheses, nothing in them, and that will just print. That'll print a blank line. Kick it down another line. Now, other things that we can do while we're printing stuff out is we can actually we can have it calculate things. We could say x plus cost. We could add these together. Now, it doesn't actually add them together anywhere and store it, but it prints it out. So let's see what happens with that. We should get an extra blank line now, and then it should add X and cost together. Now, X was 5 and cost was 199. So is it going to print out 699? Let's see. Compile, close, right click, 699. Okay, so it did. Add them together. Let's see. We can now, let me start showing you some other stuff. There's a whole math class, okay, that has a bunch of, one of the things about object-oriented programming in general, is that you want to be able to use other people's code that has already been created to do basic things you want to do. So in the math class, capital M, there's a bunch of different mathematical operations. So SQRT is square root, and then you put X into it. And then I always want these extra spaces at the beginning of parentheses and even here and at the end, because it makes it really easy to see what's inside of it. It kind of breaks it up a little bit. Now, X is 5, so what's it going to do? Is it going to print out what the square root of 5 is? Some decimal, right? So let's see, compile. Let's see what it does. Right click, void main string, okay, and it gave us this decimal, long decimal. Now it probably stores more places than it displays, but all right. So that particular method gives you back a double type, even though it takes it, we put an integer into it and it gave us double back. Let's see if we put cost into it. Would it work if we put a double into it? Because certain methods require certain types of things to be given to them. Yeah, we can do that. Yeah, it works. Square root of 1.99. Okay. So I'm going to clear this. We're almost done with this first one. And then I think you have what you need to start the very first assignment. Now there's this other interesting thing, system.out.println. This is just a way for us to print things out so we can see what's happening. A lot of times you're going to print things out even if later you don't want to, just to kind of see what's happening. Now in the integer class with a capital I, there's something called max value, and it's all capitals. And that in Java is usually used for what we call constants, things that we don't want to change. And so Java can only store up to certain size numbers, negative and positive. And so this is a way for you can do min value, I think, too, to see what that largest number is that Java can store. And there's some things that happen if you do things that would go past that number. So this is the largest number Java can store. That's thousands, millions, billions, like 2,147,483,000. So that's the largest number you can store. We could see what the smallest number it can store. And smallest not in the sense of like tiny, but as in most negative. So another thing that you could start doing is you can copy and paste one line of code that is going to be very similar to another one. We do min value. Okay, let's see what this does. Yeah, so the min value, you'll notice it's actually almost the same, but it's one number smaller. And that's because the memory required for this, one of the spots in memory gets used for this negative. And so it gets kind of taken away from the positive. It doesn't go all the way up to 848, where this one goes down to negative. So that's it for this. I want to go and help you start your first assignment, which, so let's say we close this and we go in here. My internet needs to be reconnected. Let's see. Okay. So in this folder, the Unit 1 folder, you're going to find Unit 1 Fundamentals Assignments. And I want you guys to work on P1A. It's a very simple program. I want you to retype everything. I don't want you to just copy and paste all your code and just tweak it. I want you to get used to typing the basics. If you don't do that, you're going to get stuck when you don't have anything to copy from, which will be like on your test. So go to this. Everything's gonna be digital in this class. So using MyFirstApp.java as a model, don't copy and paste it. Write a similar program. They're saying use that as like notes, as a reference. My second app that prints your favorites. Your program should print your favorite food, your favorite color, favorite movie, favorite music group, each on a separate line. So it's gonna be very simple. It should take you 5 minutes, 10 minutes maybe. Now, what you're going to do is you're going to go to BlueJ and open it up if it's been closed. And it's probably going to open up that last thing that we were working on. So what we're going to do, I guess you could have it open and you could say project. You want to go to project. You need a new project for every assignment. Every assignment problem needs to be a new project. I don't want them all in the same project. They need to have their own folders. So you go to new project. I'm going to help you start out right now. Click on new project. We want it in the Unit 1 folder. Perfect. And we're going to call it P1A. Okay. And then your second assignment problem will be P1B and P1C. And so this is what we're going to do in every unit. But in Unit 2, it's going to be P2A, B, C, D. P1A project. This is exactly what I want everyone to name it. And it's going to create its own little folder. Now, by the way, if we go back to this folder, you'll notice in the P1V project that we were doing together, that it has all these different files now that get created when we compiled it. This is the thing that runs it. If you just double click, it'll open it up. Now, we'll go back to Unit 1. Now we have a new folder for P1A. Okay. So in here, P1A project, you're going to say new class. This is where you get to choose the name or whatever. Now, I think I encouraged you to use a certain name. I said, let's see, I can go back here. I said, call it my second app. Okay. So I'm going to say my second app. Camel notation, capital letter first. Okay. Creates it. You're going to double click it. You're going to get rid of everything in here. Okay. And then you're going to start typing public class my second app. You do the curly braces. Now it just automatically, let's see. And then you're going to close them and you're going to comment them right away. End class my second app. Okay. And you're going to start typing everything else. Now, the one thing that you need for sure in this program and all the programs that we're going to do is public static void main parentheses string with capital S args regular brackets close parentheses. So every one of our programs is going to have that. What you should probably do is try and memorize that. And that's going to be in method main. Okay. And then this is where you're going to type everything in here. So you need to, yes, you're going to use these other programs as reference, but only as much as possible. You want to be able to do this from memory quickly. The more you do it, the faster you'll get. So go ahead and try this assignment and we'll talk about it next time. I'm going to hit compile to save it. I'm going to close it. If we go back to our folder, the P1A project now has its own set of files. So each project needs to have its own folder, P1A project, P1B project, P1C, and then the nice thing is they'll all be listed in order in your Unit 1 folder. So that's it.